Hello and welcome to the Scientific Adventures of Beardman. Today we're going to be looking at a concept builder on physicsclassroom.com in the topic of kinematics, and the title is Graph That Motion. First, this is going to use cars running along, leaving dots behind, dot diagrams or ticker tapes. I'm going to link here my videos on acceleration and dot diagrams or on match that motion, I think, that talk about dot diagrams. So you'll see both of those here. So if you are unfamiliar with dot diagrams, please take a look at that. It will help you significantly. Okay, so there are two types of graphs you have to be able to identify, and that is position time graphs and velocity time graphs. We'll start by talking about position time graphs and then move on to velocity time graphs. So first of all, a position time graph you see has position on the y-axis, time on the x-axis. And so therefore it shows us where something is at a certain time. Now the easiest way to do this is to think of a space and picture a number line across it. So you're sitting in a room right now. If you're in the center of that room, picture that as position 0. The far wall on your right could be position 6, and the far wall on your left could be position -6. Or you could use meters. The numbers aren't super important, but this is over on the right side, this is over on the left side. Okay, so on our graph here, this would be a big positive number up here, which means this is on the right. And this would be our 0, which would be the middle of the room, or if you prefer, you could picture it as being the left side of the room, and the next room over is the negative numbers. Since for the position time graph, we've only got quadrant 1, we end at 0. Okay, so this will be our left side of the screen or of the room or whatever the location is. Okay, so as we take a look at this, of course, time is being measured down here. So this is the start time. Some people can get confused and think that that's the left side because it's the left side of the graph, but that's the starting time. So where is the car at the beginning of the motion? And then over here will be the end time. Okay, so it's going to go from right to left, from start to end. Okay, all right. So let's see. Let's go ahead and take a look at the first statement here. So slope 0 means an object is standing still. Well, what does slope 0 look like? Slope 0 would look like that. Okay, in other words, its position has not changed. Now, it doesn't matter if this is taking place at the top of the screen or the bottom of the screen or at 0 or somewhere in the middle. It's keeping the same position the entire time. That's the definition of standing still. You're keeping the same position the entire time. So anytime you see a horizontal line where the position is not changing, that means that the object is standing still. Slope 0 means standing still. A small slope. So now if we picture something with a small slope, it could be this way or this way. Well, in that case, if it's got a small slope, its position has changed, but it hasn't changed very much. And it took a long time to change just a little bit. So that means if it's taking a long time to change a little bit, we define that as going slow. Okay, it took a long time to go a little distance. That's what snails and turtles do. They take a long time to go a small distance. Okay, on the other hand, a steep slope, something like that, okay, those would change a big distance. Their position would change a lot in a very short time. Okay, so a steep line. The steeper the line gets, the faster it's going because it's covering a big position in a small amount of time. Okay, let me go ahead and clear this. Oh, eraser. Oh, perfect. So often, so lines that are just sloped, you've got an idea of. But throughout the course of the car moving, it might move at different speeds at different times. So you'll tend to see graphs that look like this an awful lot. Well, what does that mean? It means at the start, okay, at the start, it's almost horizontal. So it's stopped and then it's going really slow. But at the end, it's going really fast. Not only that, it's starting on the left side and it's moving to the right side. It ends at the right side. Okay, so it starts out slow, it ends fast, it starts left, and it ends right. Okay. Of course, we could start left and end right, but have a different slope. Let me get that here. Okay, pen. So what if it went like this? What would that be telling us? It tells us that it's starting out fast, because that's a steep slope, and it's ending up slow. Okay, so that would be different, but it would still start on the left and end on the right. Okay, of course, we could have it start on the right and end on the left. Start on the right, end on the left. Either of those would start on the right and end on the left. One would start slow and end fast. One would start fast and end slow. Okay, so keep these in mind here. And then the last thing is that sloping up means moving right. We kind of talked about that. You're moving from the left to the right if it's sloping up, up, up. Any of those are sloping up. Sloping down, like these ones, or a straight line down, would mean that it's moving to the left. It's starting out on the right side and it's ending up on the left side. All right, let's move on to some sample problems. Okay, so we're going to take each of these going from left to right first. So imagine the car starts out over here, car, UFO, whatever, and it ends up over here, probably goes off the screen. Okay, so this one starts out on the left. Well, the left side would be over here, so it's going to start out down here somewhere, and it's going to end up there because it ends up on the right side. Okay, this is left, right, and this is right. This is left correct, and this is right. And then the question is, well, what does this mean? Well, according to our dot diagrams, this isn't going very far each second. So as each second passes, the speed doesn't, or the position doesn't change very much. Okay, but as it keeps going, that position changes by more and more each second. So this is going to be a curved line like that. All right. Number 2, remember we're still looking at going this direction. So this one, they're all evenly spaced up. Okay, so that means it's going the same speed the entire time. Starts left, ends right, same speed the entire time. Every second, it changes by the same position. Every second, same position. Every second, same change in position. Okay, so that's what that one would look like. I'm going to jump and do number 4 here next, just because it's another one where they're evenly spaced. But this one, they're closer together. That means it's moving slower. And remember, moving slower would be a line that's not as steep. Okay, it'd still be a straight line because it's constant speed. Speed is not changing, but it's a slower constant speed. So it's not as steep, it's flatter. All right, and our final one, we're going to do number 3. Once again, we're still talking about going left to right, so we're going to start at the bottom and end at the top. And we start out going really fast. Well, really fast because these are far apart. That means we've gone a long distance in a short time. Long distance, short time. But then they get closer and closer together. Okay, so that means it's slowing down. And eventually it might be stopped. Okay, so that's what number 3 would look like. Let's do all of this for the reverse direction. Let's just say the car was going that direction. Well, if it's going that direction, it's starting on the right and it's ending up on the left. This one starts out slow. Slow means a flat slope or flatter slope, and it ends up going fast. So that's a steeper slope. I just did this backwards. That's a mistake a lot of you will make. So I wish I could say I did that on purpose, but I did it on accident. So let's go ahead and do that right. So we're going left to right. So where does it start? It's starting over here, right? The car started over here and it went that direction. So it starts out going fast. Fast is a steep line. It ends up going slow. Slow is a horizontal line or an almost horizontal line. Okay, and so that's what number 1 would look like. Okay, it's going left to right, so it starts out fast and it ends up slow. All right, let's clear that. Let's go to this one. Once again, it starts out on the left, it ends up on the right. It's going at a constant speed, and so we get that. Here we see, we'll jump to number 4 again. Once again, it's doing that slower. So it'd be a line like that. Since it does eventually get to the same place, we'd technically have to keep going until we got to the same height here. But that's off the screen, so we won't worry about that. But it wouldn't be as steep. It would be a more sloped line. All right, and finally, we've got number 3 going this direction. We start on the left, we end on the right. Sorry, we start on the right, we end on the left. And we start out going pretty slow here. So that's like that. We end up going really fast. So we end up going fast. Be a curve, something like that. All right, and that's what you will see in this concept builder. All right, let's move on to the second kind of graph. Second kind of graph is a velocity time graph. So now we're no longer talking about where something is. Instead, we're talking about how fast something is moving. So this graph, when we're on at a particular point in time, at that point in time, this is its speed. That's what the speedometer is reading. Okay, your speedometer doesn't tell you where you are. You have to look at your GPS for that, right? This is telling you what your speedometer is reading. So just how fast. It's a big mistake people make. This does not show us where the object is. Okay, it does not show where the object is, only how fast it is going. Okay, so it could be way over on the right, way over on the left. It depends what direction it's going. So what does that tell us? Well, the positive side means that it's moving towards the right, because the right side of this number line is more positive numbers. So whether you're over here moving right or over here moving right, that would mean you're up in this part of the graph. So anytime you see any line up here, your car had better be moving right. Okay, the opposite of that is true as well. Whoops, that's not there. But down here in the negative section would mean your velocity is negative. That would mean you're moving left. Okay, so moving left is a negative velocity. Okay, next, sloping towards 0 means slowing down. So on either side, if you're sloping towards 0, because this is 0 velocity, this means stopped. Anytime your marker is on this line, it means you're stopped. If you're crossing it like that, at the moment where it touches, at that instant, you are stopped because your velocity is 0. Okay? You were going right. You crossed at that time, you're not moving at all, and then you're going to the left in the negative direction. Okay, so sloping towards 0 means slowing down. Sloping away from 0 means speeding up. You're starting out stationary and you're going faster and faster. You're going faster and faster. Faster and faster to the right, faster and faster to the left. Okay, let's do our 8 graphs on velocity time. Okay, so once again, keep in mind this would be stationary. 0 is stationary. Okay, so let's take a look at the first one. We'll go left to right. Keep in mind that does not tell us top or bottom of the graph. It tells us the fact that we're going right means all of our stuff is going to be up here in the top half of the graph. Okay, because we are going to the right across here. So it starts out going slow and it speeds up. Slow is close to 0. So this line would be going like this. It's all in the top part because it's moving to the right. To the right means a positive velocity. Positive velocity. We're starting out close to 0, going slow, and we end up going really fast. Okay, remember this is still the end and the start. All right, so then start and end. Okay, so the number 2 We're moving to the right with a positive velocity that is not changing. So there's number 2. Positive velocity, not changing. Same velocity the entire time. Number 4, same velocity but slower. So the speedometer is reading a lower number, closer to 0. And so that would be 4. Same velocity the whole time. All right, number 3 we see here is going this direction. It starts out going fast, a lot of distance each second. So that's up here close to the top of our graph. And by the end, we're going slow. Maybe we even come to a stop and hit 0. Okay, so we're getting closer and closer to 0 as time goes on. All right, let's flip that around then and take a look at it going the other direction. If we imagine it going this way, first of all, we're going left. That means we've got a negative velocity. We're going towards more and more negative numbers, or a change is negative. 4 to 1 is a change of -3. So we got a negative velocity because our position is changing in the leftward direction towards more negative numbers, smaller numbers. Okay, so in this one, we're starting out going really fast. So far from 0 is going really fast. We end up going slow. That's close to 0. And so our graph would look like that. We went from fast to slow. Beginning at the start, we're going fast. We're far from 0. And we end up going slow, close to 0. Okay. Then if we do our 2 constant velocity ones, the constant velocity at 2 is faster because it's farther apart. It's going farther each second. That means our speedometer is reading a higher number, but a higher number in the negative direction because we're going left. So that would be 2. And then this would be 4 because it's not going quite as fast. It's going a smaller distance each second. Okay. So then finally, number 3 here, we see going this direction because we're doing left right now. The car moves from the right side of the screen to the left side of the screen. It starts out going slow. Slow and to the left is just below 0, but it's close to 0, 0 speed, 0 velocity. And it ends up going fast. That's farther away from 0. And so that graph would look like that. All right, so that will get you through the apprentice level, okay? Understanding velocity time graphs and position time graphs. For the master level, you have to combine them. We're going to do this going both ways as well. So in this case, you have a 3-stage motion. The car kind of putts along here, if we're going this direction, at a fairly slow speed. Then you can see the dots are all clumped up here. You'll actually see the car stop here for a little while. That means it's standing still. And then you'll see it move this way. Dots are getting further and further apart. It's accelerating. Okay, so let's take a look at a position time graph. So it starts over on the left, way down here. Remember, this is the left and this is the right. This is the start and this is the end. So it starts out over here on the left. It moves at a constant speed, meaning the position is changing the same amount each second. Excuse me. The position is moving the same amount each second, and then it stops. Well, what is stops on a position time graph? It means its position stays the same, or a horizontal line. Then we see it starts out moving slow, still to the right, getting farther towards the right, but each one is getting farther and farther apart. Okay, meaning it's going faster and faster. So it starts out slow, which is close to horizontal, and then it ends up going fast, which is close to vertical or steep. All right, so that is what your position time graph would look like if this car was going to the right. Let's look at the velocity time graph. So moving at a constant speed in the right direction would be something like this. Okay, it's moving kind of slow. The dots are close together, so it could even be lower, but that's the basic idea. Then it stops. What's your speedometer read when you're stopped? it reads 0. So this will drop down, and it couldn't actually be vertical there, but for our purposes, we'll make it vertical. And it stays at 0 for a little while. And then it begins to speed up. So its velocity is changing from 10 to 20 to 30 to 40 to 50. Okay? And so we see it sloping up like that because at each second it's going faster and faster and faster at in a constant way. Okay, so we get a horizontal line with a positive velocity, a horizontal line with no velocity, and a sloping line showing us that the velocity is constantly changing. All right, let's take a look at this going the other direction. Let's say this was going this way to the left. So first of all, the position then starts over here on the left. I'm sorry, that's not left, that's the right. Okay, left, right. Let's just start that over. Okay, so position. This is the right, this is the left as usual. Okay, and this is starting on the right. So that means it starts over here. It's moving fast, so that means it's going to be a steep line. Okay, so we see a steep line that mellows out, that gets flatter and flatter as these get closer and closer together. Then it's horizontal for a while, that's standing still here. And then it continues at a constant rate, which would be a straight line sloped down, once again moving towards the left. Okay, so the whole time we were moving from right to left, except for when we were stopped and our position didn't change. All right, on the velocity time, we're now moving to the left. That means we got a negative velocity because we're moving this direction. We start out with a very big negative velocity, so up here, okay, and we end up getting to stopped. Okay, so big negative velocity, we end up stopped. We stay there for a little while, meaning our speedometer reads 0, our velocity is 0, and then we continue moving to the left at a constant velocity, something like that. Okay, this means that our change is happening instantaneously, which can't actually happen, but that's what we're pretending here and helps you understand the concept for the 3 sections. So focus on the 3 horizontal-ish sections. Okay, where time is passing. All right, then finally, the wizard level just takes and puts together the two things. So you'll see stuff that looks like from your apprentice level with just one section, one time period, and you'll see stuff from, this should say, master level, which has the 3 different time periods in it. So make sure you look at it carefully. Come back and check out some of the graphs that I showed you as examples, and enjoy learning physics. If you enjoyed this video, click the like and subscribe button. If you have any questions, feel free to put them in the comments below, and we'll catch you the next time on the scientific adventures of Beardman.